So today we're going to be estimating square roots as decimals. One of the things that we're going to be challenged with this year is being able to figure out what a square root of a non-regular number is without using a calculator. And this is based off a method called Newtonian method that you're going to use later on in calculus. But really for us, it's going to be a modified version of trial and error. What you're going to do is to start out, we need to know our square tables, usually about up to 15 at this point. So let's go ahead and let's fill out on the side our square tables up to 15. And so when we square all these numbers, we know we're going to get these values. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. Okay, and so we know that when we're looking for these values, I'm going to be looking for 14 in my perfect table to see between what two values it falls. So that's where I'm going to start. And as I see creeping up the table, 16, it is beneath 16, but it is above 9. So I know it's going to be between 9 and 16. I know it's going to be between 3 and 4. So my guesses are going to be between the numbers of 3 and 4. Being as 14 is really close to 4, what I'm going to do is I'm going to pick a higher value. I'm going to pick something like 3.8. And I'm going to go ahead and I'm going to square it. And now, when I square this, I'm just going to go through and I'm going to old school multiply this. I'm going to multiply my ones column, which gives me 64. And I'm going to carry my 6. And then multiply my ones times my 3. 3 times 8 gives me 24. Plus my 6 is going to give me 30. I'm going to move over and put my placeholder and move on to my tens. Or in this case, my ones, because it's a decimal. 3 times 8 is going to give me 24. And carry my 2. 3 times 3 is going to give me a 9 plus my 2, which is 11. I'm going to add these up. So I have 4, 4, 4, 1. Because my original problem had 2 decimal places, I'm going to need 2 decimal places in my answer, 14.44. That's a little higher than 14, so my guess was a little aggressive. I'm going to pick one a little smaller and go 3.7. And check to see if I fall beneath 14, and then I'll know it'll be between these two values. But as of right now, let's go ahead and check it out. I'm going to multiply my ones, or in this case my tenths. 7 by 7 gives me 49, carry my 4. 3 times 7 gives me 21, plus 4 is 25. Move over, put my placeholder. 3 by 7 gives me 21, carry my 2. 9 plus 2 gives me an 11. I get 9, 6, 3, 1. And yes, somewhere between 14.44 and 13.69 exists 14. So now my answer is going to be between these two values. So if we're going to round to the nearest 100th, I'm going to say my answer is 3.7. It looks like it's roughly right between them. Maybe a little closer on the lower end, so I'm going to say 3.74-ish, roughly. And that's just a good guess. We don't know exactly where it's going to be. Let's try another one. Square root of 48. I need a starting guess. So I'm going to look on my table and see when I 49 is really close. It's somewhere between 6 and 7. It's going to be right up against 7 because it's right up against 49. So I'm going to be a little more aggressive here, and I'm going to pick, let's say, 6.9. And I'm going to square that. I'm going to go through, I'm going to multiply. My ones give me 81. Carry my 8. That gives me 54 plus 8, which is 62. Hold my 0. That gives me 54. Carry my 5. 36 plus 5 is 41. 1, 6, 7, 4. 4761. Now, between 4761 and 49 is where my number exists. So I know my answer is somewhere between 6.9 and 7. So I'm going to pick an answer. Let's see, it's about 4 away here, and it's about 1 away there. I'm going to lean more towards 6.9. So I'm going to say it's roughly 6.9, let's say 2. The idea is that we know the first two. We know the ones and we know the tenths, and you're guessing on the next digit. And this is what the point of this lesson is to know 2 values and to guess a third. Now, can we know more? Yes, we could. I could go further on and try out 6.92, try out 6.93, and continue to work my way down until I have another decimal, and another decimal, another decimal. And that's actually where the Newtonian method comes in, is you continually add degrees of credibility to your answer. That's not really the point of the lesson today. We just want to get down to 2 decimals. If I have one that I'm multiplying by 2 on the outside, I need to do the same method. I'm going to find the square root of 67 to some degree of certainty, and I'm going to double it. So let's scroll down our table and see when we pass 67. Right there. So it's between 64 and 81, which means it's going to be somewhere between 8 and 9. I'm guessing closer to 8, which means I'm going to pick, let's say, 8.1. So I'm going to try and take 8.1, and I'm going to square it, see where it takes me. I'm going to multiply my ones. 1 times 8 gives me 8. Move over with my 0. 1 times 1 gives me 8, and then 64. Add up my values. 1, 16, 5, 6, 65, 61. Still a little low. So I'm going to go a little higher. Let me try 8.2. See where this takes me. 2 by 2 gives me 4. 2 by 8 gives me 16. Move over with my 0. That gives me 16. Carry my 1. 64. That's a 65. Add up these values. 4, 12. Carry my 1. 7, 6. Oh, hey. So somewhere between 65.6 and 67.2 is my answer. So I'm going to assume that this is roughly equal to 2 times, well, I know it's going to be 8.1 something. Looks like it's closer to 8.2. So I'm going to go with, let's say, 8.19. Is that 100% accurate? No, but I know it's at least 8.1. And then with this, I'm going to work this out. So 8.19 times 2, 18. That gives me 2 plus 1 is 3. That gives me 16. So my answer is roughly equivalent to 16.38. There we go. I have the square root of 115. I look down my square table until I pass it. Oh, right there. So it's somewhere between 10 and 11. So 115, it's leaning towards 11. So I'm going to go with, let's say, 10.7-ish. So I'm going to say 10.7. I'm going to square it. 7 by 7 gives me 49. Carry my 4. 0 plus 4 is 4. 7. Hold my 0. 0 to 0, 0. 0, 0, 0. Now I'm going to hold 2 zeros, and then I get 7, 0, and 1. I'm going to add up these values. 9, 4, 4, 1, 1. I have 2 decimals, so I know I have 2 decimals originally. Ooh, that was really close. 115 and 114. I'm just a little under. I bet you my next one, I'm going to be just a little over. Let's try it out. So if I go 10.8, I'm going to go 64. 8 times 0 is 0, plus 6 is 6. 8 times 1 is 8. And then this is where I multiply everything by 0 from the 1, or from the 0 from 10.0, or 10.8. I put my 2 placeholders, just to make sure I know the difference. 1 times 8 is 8. 1 times 0 is 0. 1 times 1 is 1. Add up these values. 4, 6, 16, 1, 1. Yep. I know somewhere between 114 and 116 is 115. So I'm going to take a look. It's really close to this one, so I'm going to pick a number much closer to 10.7. So I'm going to say this is roughly 10.71. And then I'm going to multiply it times 8. So 10.71 times 8. 8, that's 56. Carry my 5. 8 times 0 is 0, plus 5 is 5. And 8. 8568. So this is equal, roughly, to 8568. Awesome. Now the last ones, instead of multiplying, I'm going to find where the square root is, and then I'm just going to add 2 to it. So I'm going to scroll down my table until I find the square root of 218. Ooh, that's right towards the end. So it's going to be somewhere between 14 and 15. Probably closer to 15 because it's only 7 away right here. And as we can see, towards the later numbers, the gaps are bigger, so you're going to know where to lean. Up top, they're really close. It might be a little difficult to guess. So I'm going to pick a number close to 15. Let's say 14.8. I'm going to square that and see what I get. Add up these values. I have 2 decimals originally. I have 2 decimals here. 219.04. So it's a little high this time, so I'm going to have to pick a number that's a little lower. Let's try 14.7. And we do the process again. Two decimals. Hey, so somewhere between 219 and 216 exists 218. So I know that my guess is going to be, looks like it's a little closer to 219, so I'm going to pick a number a little closer to 14.8. So I'm going to say, I know it's at least 14.7. And then I'm going to take a guess at the next one. I'm going to say 14.77. 2 plus 14.77, and I'm going to get roughly an answer of 16.77. Okay. Last one we're going to do is I need to find the square root of 99. I'm going to scroll down my table until I hit the square root of 99. Oop. Somewhere between these two values, right up against 100. It's probably going to be right up against 10. So somewhere between 9 and 10. I'm going to pick 9.9. And I'm going to square it. We're going to have lots of 81s here. 9 by 9 gives me 1. Carry my 8. 81 plus 8 is 89. 1 by 0. 81. Carry my 8. 81. 89. Add up those values, 1, 0, 8, 9. 9801. That's a little lower than this, but I can't go any higher because if I square 10, I'm going to get 100. So I know it's somewhere between 9.9 and 10. So I'm going to say, let's see, it's a little under a 1 away, and it's exactly 1 away, so it's closer to 9.9. I'm going to say, let's go maybe 3.9.94. And let's see where we're going to get. Now when I subtract 9.94 from 3, I'm going to get roughly, this is my first, negative 6.94. And that's all it is on estimating square roots, is we find between what numbers it exists, and then we trial and error again and again until we find the first two. So here we knew the first two numbers, or the first number. I knew it was 10.7 and I guessed on the 1. Over here I knew it was 8.1, I guessed on the 9. Here I knew it was 14.7, I guessed on the 7. Down here I knew it was 9.9, I guessed on the 4, and we're good. So today we're going to be estimating fractions as decimals, which means we're going to have to use something called long division. Now I know there's multiple methods to divide fractions or divide any two numbers, but the reason why we're going to use long division here is because later on in the course we're going to have to use something called polynomial long division, which works exactly the same. So even though you might have learned a cool trick in another school, in another grade, we're going to use long division because we're going to need this skill later on. So let's go ahead and let's start with number 1. I have 150 of something, and I'm trying to put it into groups of 8. And I want to see, okay, what is 150 divided by 8? Well, if I'm going to round to the nearest 100th, that means I need to see how many groups of 8 can I fit in 150. Which means that I'm going to first see if I can't plug 8 into 1. And I can't. 8 doesn't fit into 1. So I'm going to say 0 times 8 is 0. And I'm going to subtract. 1 minus 0 is 1. And I drag down the next number. And I repeat. That's all long division is. You've seen every single step. Now I'm just going to repeat it several times. 8 fits into 15 without going over once. It can't go in twice because twice would be 16, which is greater than 15. So I'm going to take that 1 multiplied by 8, and I get 8. And then subtract. So 15 minus 8 is 7. And I'm going to drag down my 0 and do it again. So 8 fits into 70. 8 times without going over, because 8 times 8 is 64. If I have another 8, if that were to be a 9, I'd be at 72 and it won't work. So if I take there, I'll get a remainder of 6. Now, I need to round to the nearest 100th, which means I can't stop right here. I need to keep going. So I'm going to add a decimal and a 0 to allow myself to keep doing the same process. As a side effect, that also means my answer is going to have a decimal at that same spot. So 8 fits into 60. Well, if that was 8 times, I'm only going to get 7 times this go around, which means 56. So we notice how a lot of this is knowing your times tables really quick. You're like, okay, 8 times 8 is 64, 8 times 7 is 56. So that might be a skill we need to practice. This is going to give me a 4. I need another 0. 40. I know that fits in 5 times exactly. And what ends up happening when I have a 0 down here, I can stop. So to the nearest 100th, my answer is exactly 18.75. Awesome. Let's try it again. On number 3, I have 195 that I'm dividing into 8. So I want to see how many groups of 8 can I make out of 195. So I'm going to try and plug 8 into 1. It doesn't work. 0 times 8 is 0. And I'm going to subtract it. and drag down my next number. Do it again. 8 fits into 19 twice without going over. I'm going to subtract it. 8 fits into 35 4 times. And now I still have a remainder going on, so I need to add another 0 to be able to continue my process. Which means if I've added a 0 onto the end, I have to add that decimal to my answer as well. So if that was 4, I know I can only fit 3, which is going to be 3 times 8 is 24. I get my 6. Okay, so this is going to look familiar from this point forward because I'm bringing down a 0. I know it's going to fit in 7 times, which is going to be 56, because 7 times 8 is 56. And right now I'm at my 100th position. So I just need to see what this next answer is going to be by bringing down my next 0, even though that's the 1000th and not technically required to find 100th. We need to know, do I round this up or do I round this down? So I'll notice that I fit in exactly 5 times for right there. I don't need to do the next step because now that I figured out it's 5, I can stop. And I'll remember the rule that if the decimal ends in a 5 or greater, so let's say 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So if the decimal ends in a 5 or greater, I know this is going to round up to a 1. If the decimal ends in a 4 or less, this is a round down. Rounds down to a 0. So if it ends in a 5 or greater, I round up. So that means that that becomes an 8. So this is equivalent to 24.38. Awesome. And then each one of these, we're doing the same steps. If I take 180 and divide it by 6, I'm saying how many times does a 6 go into 180? Well, 6 fits into 1 0 time. 0 times 6 is 0. Subtract it, drag it down. 6 fits into 18 3 times. For 18, I subtract it, bring down the 0. Now you might be tempted to stop here because you're like, hey, I have a remainder of 0, I'm done. But let's ask ourselves, if I have 180 students and I need to split them into groups of 6, I can only make 3 groups? No, the answer shouldn't sound right because we haven't finished yet. We haven't hit our decimal. So we're going to keep going through this process until we have to look at the decimal and say, do I need to bring more in order to finish the problem? At this case, 6 doesn't fit into 0. I know that I can stop right there because I don't need to bring down any more because I'm already at 0. So in this case, I know my answer is exactly 30. Which brings us to one of our last points. I have equals 18.75, I have equals 30, and I have a squiggly equals 24.38. What that means is that if I have a hard equal sign, that means the answer is exact. There was no rounding necessary. I know that's exactly 0.75, I had a 0 remainder. I know that's exactly 30, I had a 0 remainder. For right here, what was my remainder when I stopped? 4. So that must mean that if I have an equivalent, I must have rounded. Awesome. So let's move on to something with an additional step tossed in. So if I'm taking negative 18 and I'm multiplying times this fraction. Now, some of you might notice this fraction cross reduces. We're going to ignore that for right now. And we're just going to move forward with saying, let's reduce 147 divided by 3. So I want to say how many groups of 3 can I make out of 147 students? So I plug the 3 into the 1, I multiply, I subtract, and I drag. 3 fits into 14 4 times, I multiply, I subtract, and I drag. 3 fits into 27 9 times, I multiply, I subtract, and because I have a remainder of 0, I don't need to drag down anything else. So I know this is actually saying what is negative 18 times 49? And so this is kind of like what we did yesterday, where I'm going to take 49, multiply it times 18, 2, carry my 7, 4 times 8 is 32, plus 7 is 39. Hold my 0, multiply 1 times 9, 1 times 4. So I get 2, 8. So I know my answer is exactly negative 882. Awesome. The last one, let's do it one last time. Trying to find, for groups of 156, or out of 156 students, how many groups of 2 can I make? Well, 2 goes into 1 0 times, multiply, subtract, drag. 2 goes into 15 7 times, multiply, subtract, drag. 2 fits into 16 8 times, multiply, subtract. Don't need a drag because again, I'm at my decimal. So this is actually saying what is negative 4 times 78? 78 times 4 is 32, carry my 3. 28 plus 1 is 312. This is exactly negative 312. That's it. So today we're going to be working with operations with fractions, and mostly we're going to be dealing with multiplication and division of fractions. Now, with multiplication and division, we need to make sure that we're following 2 rules. When we multiply, we make sure that we multiply straight across. And when we divide, I know there's several methods out there that we can use for division. We're going to do the method where we keep the first fraction, we change the operation to multiplication, and we flip the second fraction. It's the keep, change, flip method. So let's take a look at some of the problems. If I'm multiplying 1/2 times 5/4, and we remember that the dot signifies multiplication, I'm going to multiply straight across, which means the top number times the top number, and bottom number times the bottom number, which means I get 1 times 5, which is 5, divided by 2 times 4, which is 8. And the last step is always check to see if I can't reduce it, meaning can I divide both 5 and 8 by the same number? And in this case, I can't. So that's going to be my final answer. If it's division, remember, we're going to use the keep, change, flip method, which means I'm going to keep the 1 over 6, I'm going to change division to multiplication, and I'm going to flip this fraction upside down, so I get 11 over 8. And now when I have multiplication, I can just multiply straight across. So I'll have 11 over 48. And because I cannot reduce that one, that's my final answer. On number 5, we encounter our first instance of which we're going to have to do the reduction step. Now, I know there's a school of thought that says we can reduce beforehand. I'm not going to reduce beforehand in this case, just so we can see what happens if we can reduce at the end. So, because it's multiplication, I'm going to multiply straight across, so I get 56 up top, and if I get 24 times 14, 24 times 14, I get 16, carry my 1, 9, 4, 2, 6, 3, 3. So I get 336. And so here's the part where we want to practice. If I notice that both the top and the bottom are divisible by something, I can reduce the fraction. And here what we see is I can reduce the fraction. Because it's an even number, I can divide top and bottom by 2. So if I divide the top by 2, half of 56 is going to be 28. Half of 336, well, that's going to be 150, 15 and 3. So it's going to be 168. Oh. So half of 336 is 168. I'm going to notice again that I can divide both top and bottom by 2 because they're even numbers again. So I'm going to divide 28 by 2 and 168 by 2. And I'm going to notice for a third time, I can divide top and bottom by 2, which means I'm going to get a 7 over 42. Now, in this case, they're both divisible by 7. So my last one is going to be a 1 over 6. And boom. Like I said, this problem can be fixed if we reduce the problem up front, but I want to show you what happens if we need to reduce a fraction just in general, or what happens if we just go ahead and multiply and then do the reduction at the end. I would normally encourage reduction at the front end as opposed to the back end like this, but it's however you're most comfortable. If we end up with something like this where it's division, all we do is we keep change flip so that we can proceed with the same series of steps. So I'm going to keep my fraction, 9 over 10, change division to multiplication, and then flip the last fraction, 25 over 18. And then I'm going to multiply straight across. 9 times 25 is 225. 10 times 18 is 180. Now in this case, I'm noticing that I can divide both by 5 because it ends in a 5 or a 0. So if I divide the top by 5, it fits in 45 times. And if I divide the bottom by 5, I get 36. Then what I notice right here is that both numbers, top and bottom, are divisible by 3. So what I'm going to do is I'm going to go ahead and divide by 3. So I get a 15 over 12. And again, I notice my numbers are divisible by 3. Which means that my 15 over 12, 15 divided by 3 is 5 over 4. I can't reduce that any further, so I'm going to go ahead and call it quits. So we see multiplying and dividing, you're just multiplying straight across and seeing if you can't reduce. If it's division, you keep change flip and follow the same series of steps again. But what happens if we have a series of operations? Well, remember the fact that with division or with multiplication, it's a left to right process. So what we are going to be doing is we are going to be dealing with the leftmost operation first. So when I move this over, I get 2/3 times 3/4. I will get 6/12 times that 4/5, which means I only dealt with these two fractions. 2 times 3 gives me 6, 3 times 4 gives me 12. And now if I follow this method, I can continue to just multiply straight across and see if I can't reduce. But now that we're dealing with 3 fractions, let's see if we can't reduce as we go. Which means this 6 over 12, I'm going to divide them both by 6. Which means that my rightmost fraction remains unchanged. I'm still multiplying times 4/5. But this, I divided both top and bottom by 6, which left me with a 1/2. So now, when I multiply straight across, I get 4/10. We notice that my final answer, I can also divide this by 2, which means that my final answer in reduced form is going to be 2/5. The process works the same with division. We work left to right. So what I'm going to do is I'm going to work on this left portion before I even deal with the right portion. So with the left portion, I'm going to keep the first fraction, 5/3, change division to multiplication, and flip the second fraction, 9/10. And I'm going to keep this over there, divide by 20 over 12. And then what I'm looking at is I'm only going to be looking at the leftmost set of operations. 5 by 9 is going to give me 45. 3 by 10 is going to give me 30. Divide by 20 over 12. Cool. And so here I'm going to keep, change, flip, finally incorporating that second operation, which means that my equation is going to be 45 over 30 times 12 over 20. And what I notice right here is what I'm going to do up here up top. I'm going to reduce on the front end because I really don't want to deal with these big numbers when I multiply 45 times 12. I'm going to see if I can't reduce a little earlier on. Luckily, I noticed that both of these are divisible by 15, and both of these are going to be divisible by 4. So for my left set, if I divide both top and bottom by 15, I get 3 over 2. If I divide both these by 4, I get 3 over 5. And I think needless to say, these are much easier numbers to deal with than trying to figure out what 45 times 12 is and then reducing. So I'm going to multiply straight across. I get 9 over 10. Because I can't reduce that, that is my final answer. The last one deals with what happens if we have mixed operations. And it's not going to be really any different. I'm going to deal with the first set of operations first, which means I have 15 times 2 is going to give me a 30. 6 times 5 is going to give me a 30. Divide by 30 over 36. I notice right here I can reduce this by a full factor of 30, where I can only reduce this by a factor of 6. So that means I have 1 over 1 divided by 5 over 6. And I reduced on the front end. Now I can deal with division. When I divide, I'm going to keep, change, flip. Which means 1 times 6 is 6, 1 times 5 is 5. And there we go. So this is a supplementary portion of the video because I've had several students ask me, how do I know if a number is divisible by 2, by 3, by 5, 7, so on and so forth. So I'm going to create a quick set of rules to figure out how if a number is divisible by some value. So if it's divisible by 2, 3, 5, and that's really all we're going to deal with is 2s, 3s, and 5s. Everything beyond that, we're just going to have to memorize and know our multiplication tables. So here's the rules. If it's divisible by 2, the number is going to end in an even number, which means some examples are if I have numbers like 222, 531, 608, 11724. What I'm going to be paying attention to is that last number. So what I notice is if the number is a 2, 4, 6, 8, or 0, then these are all divisible by 2. I notice that because this one ends in a 1, that is not going to follow my even number rule. If a number is divisible by 3, a trick is going to add the digits, and they end up as a multiple of 3. So some examples are, let's say, like 3, 6, 9. If I have 42, if I have 6, 4, 2, 1, 8, and let's give one more. Let's say 3, 4, 3. So some common things, when I look at 3, 6, and 9. I'm going to add 3 to 6 and add 6 to 9. So 3 and 6 make 9. 9 and 9 make 18. 18 is divisible by 3, so therefore the whole thing is divisible by 3. I could do it again and say 1 and 8 make 9. 9 is divisible by 3, so I know 369 works. With 42, 4 plus 2 equals 6. 6 is divisible by 3. I know that works. 6 plus 4 is 10. 10 plus 2 is 12. 12 plus 1 is 13. 13 plus 8 is 21. 21 is a multiple of 3. If we didn't recognize that, we could add 2 and 1 and get a 3. So it's even more obvious that it's a multiple of 3, so that works. A common misconception is that if the number ends in 3, it's divisible by 3. In this case, it's not, because if I add 3 and 4, I get 7. 7 plus 3 equals 10. 10 is not divisible by 3. If I try it again, 1 and 0 make 1. 1 is not divisible by 3. So I know that this doesn't work, just like this did not work. The last common rule that we're going to be looking at is if it's a multiple of 5. And what we're going to see is the number ends in 0 or 5. So this is going to show us if I have like 1, 2, 5, 0, 3, 6, 4, 5, 5, 5, 1, 5, let's say 2, 6, 1, 7. So what I'm going to pay attention to is the last number. If it ends in a 0 or 5, I know the number is divisible by 5. In this case, the number ends in a 7. It does not work. Outside of that, the best advice I can tell you is to know your multiplication tables. I'd say up to 10 for this case. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So know how to do your multiplication tables on these, and you'll know each iteration. So when you spot a number, you're like, hey, I know that's divisible by these numbers because I know my times tables. So I'm going to fill this out on high speed just so you can see how it works. And so if we see one of these numbers, we know the fact that it's divisible by 7. Outside of that, we're really only expected to know 2s, 3s, and 5s, going up to these higher numbers that are outside of this table. Otherwise, when you see the number 56, you should know that it's divisible by both 7 and 8. If you see the number 18, you know it's divisible by 6 and 3, or by 9 and 2. So you'll see the same numbers pop up on multiple spots on the table. That means they have common factors. 30, you know you'll get 3 and 10. 24, I'll get 3 and 8. 40, I'll get 8 and 5, or 4 and 10. This is the best solution. If not, these 3 rules should suffice. So today we're going to be dealing with operations with fractions where we're adding and subtracting. Now, with adding and subtracting, we need something called a common denominator, which means the bottom number on each fraction needs to be the same thing. Now, a common denominator is just a different phrase of saying they need to have the same multiple, where both numbers can effectively be added or subtracted. And this might feel like a counterintuitive step because we are unreducing the fraction. And a lot of students want to re-reduce it as soon as they've found that common denominator, so we need to resist that impulse. So let's go ahead and get started. Now, what I notice is that because both my fractions are over 2, I notice that my whole fraction is going to be over 2, which means I'm going to have a 1 plus a 5 up top. They have a common denominator, so I put them over the same thing. I get a 6 over 2, which in effect can be reduced by dividing both top and bottom by 2, which will give me a 3 over 1, or just a 3. This works with both addition and subtraction. Because both numbers are over 5, they have a common denominator of 5. And I'll take the top as a 2 minus 7. Now, 2 minus 7, I'm going to say find the difference between 2 and 7. I know the difference between 2 and 7 is 5. I know 7 was the larger of the two numbers, so it's going to be a negative 5, which I know that this can be reduced by a factor of 5 itself. Both top and bottom can be divided by the number of 5. Leaves me with a negative 1 over 1, which is just a negative 1. So we see the process that a common denominator means that they can be added or subtracted together. Now, with the next one where we have a 4 and a 5, when we say least common multiple, what we're doing is we're counting by iterations or multiples of that number. I go from 4 to 8, 12, 16 to 20. With 5, I go 5, 10, 15, 20, 25, and I try and find a common number in both lists. And so that tells me a common multiple. I have to multiply 4. It's the 5th number in the list. So I'm going to multiply by 5. I'm unreducing it. With 5, it's the 4th multiple, so I'm going to multiply by 4, which means that if I unreduce both these, they're both going to be over 20 because that's my common multiple. And if I multiply 5 times 1, I'll get a 5. If I multiply 4 times 3, I'll get a 12. Which in this case, because they have a common multiple, I know that I'm actually dealing with just 5 plus 12 over 20, which is going to give me a 17 over 20. And because that can't reduce, I'm done. And now, we can do these lists every time. This is where knowing our multiplication tables comes in handy, is it greatly reduces the amount of writing that we need to do. In this case, I'm looking for multiples of 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, with 11, 22, 33, 44. We see the fact that if I'm not familiar with my multiplication tables, I have to do a lot of writing to find that both 4 and 11 can be found as a multiple of 44. Now, a shortcut that a lot of us know is that we could just multiply times the other denominator. That will give us a multiple, will be the least common multiple. Sometimes yes, sometimes no. But I know that 44 is the 11th number in the multiples of 4. 44 is the 4th number in multiples of 11, which means that as I work this out, I'm going to get both of them over 44. Because again, remember I wanted them to have a common denominator. I'm going to multiply 9 times 11, which is 99, and 12 times 4, which is 48. And so this way I have a common multiple of 44, which is 99 minus 48, which is going to give me, in this case, 51. 51 over 44. 51 is only divisible by 17, which doesn't share any common factors with 44, so that's going to be it. And as we continue on, we know that it can be done in chains, so I can have multiple steps. All I'm going to be dealing with in the first go is I'm only going to be dealing with these first two numbers. I could do all three. What I like to do is one at a time, so that way it keeps it simple if you're struggling. If you want to do all three at once, you're more than welcome. We're going to do all three at once down here on this go. As for right now, I'm just going to show you. If I want to find 2 and 3, I know a common multiple is going to be 6, which means that I'm going to multiply 2 times 3 to get my 6, and 3 times my 2 to get my 6. Sorry, I tried to write 6, but which is going to give me with, remember, I want both of these with a common denominator of 6. I'm not dealing with the 1/4 just yet. I'm going to leave that. So 3 times 1 is going to give me a 3. 2 times 1 is going to give me a 2. So that way I can add these two up. So I have 3 plus 2 plus 1/4. That's going to give me a 5 over 6 plus a 1 over 4. And so here, the common multiple, or the least common denominator between 6 and 4 is going to be 12. Now, if you multiplied 6 times 4, you would get 24, which is a multiple, but it's not the smallest one. If I count by 6s, I count by 4s, I notice that, yes, 24 is in the lists, but I notice that 12 is a lot smaller. So, albeit I could make them over 24, I get my numbers to stay smaller if I keep them lower. So I'm going to multiply these by 2 and these by 3. So that way they're both over a 12. So 5 times 2 is 10. 1 times 3 is 3, which means that if they're both over 12, I have 10 plus 3, or a 13 over 12. And so that's if we take it one step at a time. Many of you said, well, can't I do it to all three all at once? Yes, you can. We need to find a common multiple between 2, 5, and 12. And so if I count by 12s, because this is the largest number, to see when I'm going to encounter either a 5 or 0 or an even number. So I'm going to go 12, 24, 36, 48, 60. Ooh. It's going to be 60. So what do I multiply 2 by to get 60? 30. What do I multiply 5 by to get 60? 12. I'm going to multiply 12 by 5. And so this way, if you wanted to do it all at once, I'm going to get a 60 on the bottom of each fraction. And that way I can go it all through, all in one go. 1 by 30 is going to give me 30. 2 by 12 is going to give me 24. 5 by 5 is going to give me 25. And so what this does is I have 30 minus 24 minus 25 all over 60. 30 minus 24 is going to be 6. 6 minus 25, well, I'm going to take the difference between the two. The difference between the two is 19. I know I have a negative number over 60. Boom, and we're good. Now the last one is a little bit of a challenge. If I have a mixed number, on the off chance that you see a mixed number in this course, you're not going to see them very often, but just in case, I'm going to show you how. What we're going to do is I'm going to say, hey, I have 4 whole numbers. If I want to make them into a half, I need to cut each of those 4 into 2 pieces, which is going to give me 8 pieces total. And then what I'm going to do is I'm going to add my 1, which is going to give me a 9 halves. I'm going to do the same thing here. I'm going to break these 2's into 3 pieces each, which means 2 times 3 is going to give me a 6. And then I'm going to add that 1 left over, which is going to give me 7. And I'm going to do the same thing for my 1. I'm going to multiply that 1, cut that 1 into 4 pieces. So 1 times 4 is 4. And then I'm going to come back and add the 1, which is going to give me 5. And now I've taken mixed numbers and I've turned them into improper fractions so that I can apply the methods that we've just learned to them. So what I'm going to do is I'm going to take this one just like we did right here and find a common multiple right off the bat. 2, 3, and 4. I'm going to count by the biggest one because that's going to be the most difficult one to find and see when I get an even number and a number that's divisible by 3. So I'm going to start with, let's see, 4, 8, 12, 16. Oh, I noticed that 3, 6, 9, 12, 2, 4, 6, 8, 10, 12. Do we notice the common number right here is going to be 12? So I'm going to multiply this times 6, this times 4, and this times 3. And it's going to give me a 9 times 6 is 54 over 12 plus 28 over 12 minus 15 over 12. So I have 54 plus 28 minus 15 all over 12. 54 and 28 is going to give me 62, 82 minus 15 all over 12, which 82 minus 15 is going to give me, let's see, that's 77. That's going to be 67. That doesn't reduce, so I know I'm done. And there we go.